Hi everybody, today we're going to be multiplying and dividing fractions, but just day one. So we're going to end up doing this for 3 days, and we'll just go a little at a time just to make sure we really remember and understand how to do this. Today's focus is that you'll be able to cross-cancel to simplify and then multiply fractions. Okay, so here's a little rhyme to remind you how to multiply fractions. Multiplying fractions is no problem. Top times top and bottom times bottom. And that works. That will work every time. 1 times 3 is 3. 2 times 4 is 8. Then, if you can reduce, reduce, but we cannot. So, that works every time. But I am going to show you another way to do it that will make it much easier when you deal with bigger numbers. Okay, I am going to show you something called cross-canceling in a second, but before we do that, I just need to make sure we remember something. And I would say, what does that equal? And you would say, well, Mr. DeMars, that equals 1. And I'd say, yeah, you're right. And the reason it equals 1 is, remember, a fraction is a division problem. That means 4 divided by 4. That's what this means. And 4 divided by 4 is 1. And one way we can show that is we say 4 goes into 4 once, okay, 4, like reducing. 4 goes into 4 once, and then reduce. 4 goes into 4 once. So it's like 1 over 1, okay? Even if I were to write 4 here and 4 down here, it's the same as if I were to write them right on top of each other. There's a 4 on top and a 4 on bottom, so they cancel. So remember that. Okay, now we're ready for the next part. All right, cross-canceling. Now, if we did not cross-cancel, you would say 9 times 4 is 36, times 1 is 36. Okay, then you do 10 times 12 is 120, times 3 is 360, and you'd have all this reducing. So, here's what I want to teach you. What I want to teach you is that you can cross-cancel. And I'm going to start on this problem. So let's do this problem first. Remember how I said if you had a 4 on top and a 4 on bottom? Well, what if I had a 3 on top and a 3 on bottom? That would cancel, correct? To 1. I see that I have a 3 on top and a 3 on bottom right here. So it's kind of like saying 3 divided by 3, except they're spread out. Or 3 over 3, which is 1 whole. So what I do is whenever I see the same number on bottom and top, I cross them off and say that they both reduce to 1. Okay? So those are canceled. Now what I'm going to try is I'm going to say to myself, how many times does 2 go into 4? Okay? So what I can do is say 2 goes into 4. How many times? And 2 goes into itself 1 time. 2 goes into 4. 2 divides 4 twice. All right, then I look and I say, is there anything else that can cancel? Let's see. Now, 4 and 2 are on the bottom, so they can't cancel each other. 9 is on top. Looks like I'm done. So now what I want to do is do 1 times 1 times 9. Multiply the numerators. 1 times 1 times 9 is 9. And then on the bottom, I have a 1 times a 2 times a 4, and that equals 8. So my answer to this fraction, or this problem, is 9/8. All right, let's go back to the first problem and practice. Okay, so I see a 3 here, and I see a 9 here. Now I know it's way over there, but what if I had 9 over 3? I could divide them both by 3, and this one would turn into a 3, and this would turn into a 1. 3 divided by 3. So what I'm going to do is this. I'm going to say to myself, how many times does 3 go into 9? And the answer is that it goes in 3 times. So I'm going to cross this off and write 3. But when I do that, I have to cross this one off and say 3 goes into itself once. Now I'm going to look at the top and say 4. Can 4 divide anything down here? Yes. 4 can divide 12 how many times? 4 divides 12 3 times. So I'm going to cross this off and write a 3. And then I'm going to cross this off and write a 1 because 4 divides itself 1 time. All right, let's finish our problem. So 3 times 1 times 1. And that would be 3. 3 times 1 times 1. Then I'm going to do 10 times 3 times 1. And that equals 30. Now, I look at this and you know what? I missed something here, but that's the beauty of this. If you miss something, what I missed was there's a 3 on top and a 3 on bottom. I could have crossed those off, but that's okay. What I can do now is just reduce now. 3 divided by 3 is 1. 30 divided by 3 is 10. So the answer to this one is 1/10. All right, let's look down here. I see an 8 on top and an 8 on bottom. Perfect. Those can cancel each other. That's like 8 over 8. And 8 over 8 is the same as 1. Awesome. So those become 1s. I see a 12 on bottom and a 12 on top. Those cancel to 1. So, wow, all I have left is 1 times 1 times 1. That equals 1. And I have 1, because the 12's gone, times 1 times 4, which equals 4. Ah, that was a fast one. Let's look here. All right, I look right in the middle, and what I can do is 2 goes into 4. How many times? 2 goes into 4. 2 goes into 4 2 times. So I divide 4 by 2, and I divide it 2 by 2 and get 1. Then I look here and I say, can 2 divide any number on top? And 2 can still divide the 10. And that's okay to do. So what I'm going to do is say 2 goes into itself 1 time. 2 goes into 10 5 times. Then I look and I go, wow, I've got a 5 here on bottom and a 5 on top. So 5 goes into itself once and it goes into itself once. Wow, so then the only thing left here besides 1s is 3 and 15. Wow, I can say that 3 goes into 15 5 times. 15 divided by 3. Now I'm going to say 3 goes into itself once. So that was a lot of canceling. Now I'm going to look. 1 times 1 times 1. So the top is 1. Then I'll say 1 times 1 times 5. So the bottom denominator is 5. That's my answer. All right, so it's always good to look to see if you can cancel. And you can only cancel a top with a bottom. So can 3 and 7 reduce? No. Can 2 and 5 reduce? No. So then you're ready to just multiply. Top times top. 3 times 2, 6. 5 times 7, 35. Can we reduce that? No, we cannot. We're done. All right, let's look here. I have a 2, and what's kitty corner from the 2 diagonal? A 10. Wow, 2 can divide 10. So what I'm going to do is say 2 goes into itself once, 2 goes into 10 5 times. 1 times 7 is 7. 3 times 5 is 15. There's my answer. 7 over 15. Last one on this page, a 1 and 6 don't reduce, and 6 and 5 don't reduce. So what I'm going to do is multiply straight across. So 1 multiplied to -5 is -5. 6 multiplied to 6 is 36, and I cannot reduce that. I'm done. All right, a couple examples with whole numbers because we have not talked about those. So a question comes up, what happens when you multiply a fraction to a whole number? Like what should 4 multiply to? And remember, every whole number has an invisible 1 underneath it because 4 divided by 1 equals 4. So it's the same thing. So now I'm ready to multiply straight across. 5 multiplied to 4 equals 20. 11 multiplied to 1 equals 11. There's my answer, 20 over 11. If you wanted to, you could say 1 and 9/11. Both answers are acceptable. Now, our last one here is we have 2/5 multiplied to 8 over 1. Well, let's check. Now, we can't reduce the tops. Can 2 and 1 be reduced? No. Can 5 and 8 be reduced? No, they can't. So let's just multiply straight across. So 2 times 8 is 16. 5 times 1 is 5. Again, this answer is perfectly fine, but if you're asked to make it a mixed number, you say, how many times does 5 go into 16? And it goes in 3 times. And then 3 times 5 is 15, and there would be 1 left over. 16 minus 15 is 1. So 3 and 1/5 is also a good answer. Well, try the practice problems, and please bring any questions you have to class. Take care.